We're going to get into some precision trigonometry today. We're going to talk about degrees, minutes, seconds on Earth's surface. So if you're not really familiar with how that works, the Earth has 360 degrees because it's a circle. After that, we get into a kind of a strange way to measure. Each degree of Earth's surface has 60 minutes in it. Now, in class, I like to do a little kind of talk y'all through, get y'all having a conversation about this, but I'll go ahead and give it to you in here. 1 degree of Earth's surface is about 60 miles, so each minute is about 1 mile, so it's kind of convenient, worked out that way. If you know anything about nautical sailing, that kind of thing, it's actually 1 nautical mile, so that's actually completely on purpose, but anyway. So each minute of Earth's surface is 60 seconds, which is sort of a weird way to think about it, but each second comes out to be about 100 feet. So it's something pretty standard you can think about. So if you get down to the nearest second on Earth's surface, you're within about 100 feet of the coordinate you're looking for. So it's pretty close. The way you convert this, so before we put this in the calculator, it doesn't really have a way to do this. We need to get this to be a decimal, 10 point something. So we know it's going to be cosine of 10. We need to figure out what that decimal is. So you have 35 minutes, and I would just do a little conversion table. 35, actually, I'll put a word there. 35 minutes, well, there's 60 minutes per degree. And the reason I want to go with degree is because I want this to be 10 points, so however many degrees. So let's get that reduced down. I'm just going to pull up the calculator and do that. It's 35 divided by 60. But I do want to go with the decimal, so about 0.583 repeated. But the other catch here is I've also got 29 seconds I've got to add to that. And 29 seconds, well, first there's 60 seconds per minute. I want to get this to degrees. I think this is the easiest way to get there. And each minute, if I'm going to degrees, there's 60 minutes for each degree. So it's 29 divided by 60 divided by 60 again. Something you can use, each degree, if you work the math out here, 60 seconds per 60 minutes, there's 3,600 seconds in 1 degree of Earth's surface, so that's a quicker conversion if you want to remember that. But this definitely works. 29 over 60 divided by 60 again. So take 29 divided by 60 times 60, or if you want to go ahead and just do 3,600 at this stage, that's fine too. So about 0.008, and I'm going to add that to the answer I already got. And I'm going to take that and just do it in the calculator now. I'm just going to add that to the answer I got earlier, so I'm going to scroll up till I find my 35 divided by 60, which probably I could do just as fast typing it in, but there it is. And add that together, the result is 0.5913, 8 repeated. So I'm going to go 3 decimal places here, so 591 should be good enough. So 0.591. Now, if I'm using the calculator to figure this out anyway, something I could do is just go ahead and add 10 to that decimal I've got and then take cosine of it. So I think that's what I'm going to write down, but I'm actually going to use all the decimals in the calculator just because it's a lot more precise. So I'm just going to add the 10 to that, so I've got that whole decimal. I do want to be in degree mode, so let's make sure that that's happening. Go to mode. I am a degree. You're going to have to go back and forth between radian and degree quite a bit in this chapter, but right now we're in degree mode because we're talking about 10 degrees. And kind of a rule of thumb there, really from here on out, assume you're in radians unless you see a degree symbol. We had a degree symbol, so it's definitely in degrees. So cosine of that decimal, we're going to get about 0.9829, so we'll say about 0.983. On this example, we're going to go the opposite direction. We're going to start with a decimal amount of degrees, and we want to go to degrees, minutes, seconds. Now, I'm not taking cosine or anything like that. I'm just converting. So 25 degrees, that's the easy part. Now you got to take your 0.6789, and that's still in degrees at this point because you had 25 full degrees and that much of another one. And I'm going to take that and go to minutes. So there are 60 minutes per 1 degree. That way the degrees cancel out. So basically I'm just multiplying by 60. Once I do that, I get 40.374. Units are very important here. So we converted this to minutes now. And finally, I want to take this to seconds. So before I actually write that down, I'll go ahead and add the minutes part. We do have 40 minutes out of that decimal. And then there's this other amount left over. So what I'm going to work with is just that decimal part. So I'm going to go ahead and take the 40 out. Because I know I've got 40 full minutes, I want to see how many seconds this decimal part gives me. So of the decimal part that's left, we want to get to seconds. So there are 60 seconds per 1 minute. So we want to divide the minutes out. And basically, again, I'm just multiplying by 60. So the 0.374 times 60. And that gives me 22.44. So I recommend that you do go to 2 decimal places here. Since seconds are about 100 feet on Earth's surface, 2 decimal places get you to the nearest foot. And that's pretty precise. So I do recommend, again, 2 decimal places for your seconds part. And that'll be our answer in degrees, minutes, and seconds. All right, yesterday I mentioned about the Pythagorean family of identities. So far we have talked about sine squared plus cosine squared equals 1. We derived it, so we've seen how that comes to be. So just to see, what would happen if I took this and divided it by cosine squared? Just because I can. Well, if I did that, sine squared over cosine squared would be tangent squared. Because we know that sine over cosine is tangent. Cosine squared over itself becomes 1. And 1 over cosine would be secant. So that would be secant squared theta. And that actually leads to our next identity, which is tangent squared plus 1 is secant squared. Now what if this time you divide by sine squared? Just, again, because you can. There's really, as long as you look at both sides, there's no limitation to what we can or can't do. So let's just do it. Well, sine squared over itself would be 1. Cosine over sine becomes cotangent, but it is squared. So get that part in. And 1 over sine is cosecant. And again, that would be squared because it's 1 over sine squared. So that's your third identity. 1 plus cotangent squared equals cosecant squared. Yeah, put that down here a little more formally. That's how you could derive it. So really, if you know sine squared plus cosine squared is 1, you can easily get these other two without really memorizing them. So it's up to you. If you want to memorize and you find that easier, go for it. But you can derive these pretty quick. Most people can derive them without really writing anything down. All right, the final piece for this lesson is a proof. We want to prove that all this stuff here is equal to 1. Now, I put a big note up there in red. When you do a proof, make sure you start with one side and work it out until it equals the other side. In other words, pick one side and pretend you don't know the answer. You don't know the final result and work towards solving that. So you could pick either one. It's probably going to be pretty difficult to take one and turn it into all of this stuff. Typically, it's easier to pick the more complicated piece and simplify it down. So that's what I'm going to choose. Again, I'm going to pretend one's not there. I'm going to pretend I don't have a clue what the answer is going to be. So I'm just going to work this out and see what it comes out to be. First thing I would recommend you, or first thing that stands out to me here, is that this is a difference of squares. But it is 2 binomials multiplied together, so you do need to FOIL those out. So first times first would be secant squared theta. If you recognize this difference of squares, you realize that the middle terms are going to cancel out. But if you don't see that, let's go ahead and just work it out so that you see it unfold. So the outside terms, secant theta times tangent theta, it is negative. Inside terms, tangent theta. Inside terms are going to be tangent theta times secant theta. It is positive, but I'm going to put secant first just so it looks the same. You don't want to confuse yourself because you wrote it differently the second time. And then finally, tangent times tangent, and that's going to be negative. So tangent squared theta. So in the middle, we've got secant tangent, a negative secant tangent plus a positive secant tangent. So those add to 0, they're gone. And secant squared theta plus secant squared theta minus tangent squared theta. Well, again, we can't just, we're assuming we don't know what it equals, we gotta figure it out. In a proof, this is kind of what you call corollary because it's correlated with what's going on. So something that you know to be true, but kind of outside the main work over here, so I'm gonna put it off to the side. Something I know to be true that involves secant and tangent is that 1 plus tangent squared theta is secant squared theta. If I did a little bit of rearranging there, then I could get 1 equals secant squared minus tangent squared. So because that's a true statement, and you do have to mention that you know that's a theorem that can be done, but because that is a true statement, we can finalize this by saying that it does indeed equal 1.